Okay, straight out of section 9.3, we have a differential equation here. We're expected to find its general solution, find a particular solution given an initial condition, and then determine the value of y naught of 2 based on that initial condition. So first of all, notice that this DE is separable because I can view this as a function of x times a function of y, and I'm going to split this up as 6x squared times y. So my first step is going to be pushing all of the y stuff to the left and all the x stuff to the right. And that means that I get dy over y equals 6x squared dx. The next step here is to take the antiderivative of both sides. And so on the left I have the ln of the absolute value of y, and on the right it's going to be 2x cubed plus c. I know that technically there's a plus c on both sides, but that doesn't really matter because you can combine those and have a single c. So as long as I have one plus c, I'm good to go. Okay, the next step that I think I'm going to do, I want to kill that ln. I really want to solve for y. I want y to be isolated. So I'm going to exponentiate. And that means that on the left I have absolute value of y, and that's equal to e to the 2x cubed plus c. That whole thing is an exponent. Now, because of the properties of exponents, this is equal to e to the 2x cubed times e to the c, and I'm going to rewrite this as c times e to the 2x cubed. And yeah, that capital C is a different number from the previous capital C, and it's the same letter. I don't care. I do what I want. And so my next step is to get rid of the absolute value bars, and that's equal to plus or minus c times e to the 2x cubed, and I'm just going to rewrite that as c times e to the 2x cubed, and that's a different c because c eats plus minuses. So what are you going to do about that? Okay, so this part of the problem is completed. That is the general solution to that separable DE. I need to take that information and work on part 2, which is finding a particular solution, y naught. And really, this is just about substituting 0 for x and 3 for y and solving for c. Since e to the 0 is 1, that algebra is a complete joke, and so my particular solution is 3 times e to the 2x cubed. And I suppose I should call it y naught because the problem does. Whatever. All right, so part 3. Given that particular solution in part 2, what is y naught of 2? Well, if you were successful in finding a formula, all you gotta do is substitute 2 for x, and you get 3 times e to the 2 times 2 cubed, 3e to the power of 16. Boom.